Journey into Nature. Today is the day of a celestial summit meeting of a sorts. Journey into Nature, a special series of programs produced by WNBC in cooperation with the American Museum of Natural History, an institution dedicated to the search for knowledge in the fields of natural science. Within the many exhibit halls of the museum, you will find accurate representations of what man has learned of himself and the world that surrounds him. Journey into Nature visits many of the exhibits, talks with the staff members and research scientists in order to capture in sound the wealth of knowledge on display, to bring you the excitement of learning, to explore the wonders of the world. Here now is your host, Tex Antoine.
Thank you and good morning. For many people all over the world, this has been a long-awaited day. And since it involves planets and their positions, I have with me an old friend to talk about it, Jim Pickering, astronomer at the American Museum Hayden Planetarium. Good morning, Jim.
Good morning, Tex.
Actually, Jim, could you explain what exactly is happening today, the details?
Well, today there will be a total eclipse of the sun. Of course, that occurs whenever the moon passes so directly between the Earth and the sun that the disk of the moon completely covers the sun.
Mm-hmm.
This happens on an average of about 3 times a year. It can happen. The greatest possible number of eclipses of the sun that there can be in any one year is 5. But we usually are lucky if we can get as many as 3 out of a year.
Well, will this eclipse be seen anywhere here in the United States?
Well, technically, yes, a very small part of it. Just at sunset, the people on the extreme western coast of the United States will see just the beginning of the eclipse before the sun sets. But the best view of the eclipse would be had over the waters of the South Pacific Ocean and on some of the islands to the north of Australia. They're about the only dry spots along the path of the eclipse.
Well, Jim, there has been a great deal of talk and much written about this particular conformation of planets and, the portent and omens that it might contain. Could you, as a scientist, clarify the scientific position on all of this talk?
The 5 visible planets, the bright planets you can see without a telescope, which are Mercury, Venus, Mars, Jupiter, and Saturn, are, of course, constantly going around the sun, each in its respective orbit and at different velocities, different speeds. And in the course of time, in their normal motions, they arrive at this particular period so that as we see them from the Earth, they are all fairly closely in line with the sun. Of course, that doesn't mean that they are actually any nearer to the sun or any farther away from the sun than they always are. But it just means that they are all happen to be posted and gathered in that position in the sky so that they will appear to be very near the sun. Actually, the spread of the whole configuration of the 5 naked eye planets plus the sun, and in this case the moon because of the eclipse, can all be covered by an angle of 16 degrees, which is not a very big angle.
Oh, it's just a matter of our particular sight line.
That's right. If we were somewhere else, if we were on another planet, the whole thing would have an entirely different viewpoint. But it just happens to be the way we see it. Now, this is unusual, of course. In fact, any planetary position is unusual in that it won't take place again for a number of years. But this gathering of the 5 visible planets, plus the sun and the moon, has occurred 10 times in the last 1,000 years, which would make an average occurrence every 100 years. Of course, it doesn't work out precisely every 100 years. In one case, it's just a month apart, and in another case, for instance, an interval of 200 years will go by before this will happen again. But it's as I say, it's a purely normal result of the motions and positions of the planets as they go around the sun.
Well, man has observed the planets, particularly these, for so many thousands of years without much greater knowledge that there have been so many stories, usually associated with disaster, with the maladjustment of the planets as he is known.
Well, of course, unfortunately for the human race, there's disaster somewhere almost any time you want to elect it. And I don't see how some disaster couldn't be at the same time some position of the planets, whatever you pick out, whether it be this one or anything else, or sunrise or sunset or noon or whatever. Help yourself.
Well, that's true. I thought it's normal to seek an answer to every question that you have, and if the planets happen to be out of phase at that moment of a disaster, it would be a perfectly normal assumption that, well, this is the reason for it all.
Well, I don't know. That would be a pretty powerful assumption, I think.
Well, yes, but the personality of man is that. I know I get it from the weather aspect and the insistent attitude of some people that the new advent of the atom bomb and explosions is definitely doing something to our weather, except that the weather's always doing something, so it might as well be.
It's the same angle. The planets are always doing something, so help yourself.
Well, very good. Well, how is it, Jim, that the moon so nice and neatly covers the sun?
Well, that's simply an accident of relative position. The moon, for example, is, well, let's put it this way, it's easier. The sun is about 400 times as big as the moon in diameter. And it is also about 400 times as far away from the Earth as the moon is. So the perspective makes them have a disk of the same size as we see them in the sky. And when they do happen to coincide center for center, which is, as I say, the cause of a total eclipse, then the moon will just cover up the photosphere, the extremely bright part of the sun.
Oh, yes.
And that gives us a chance to see, naturally, the tremendous phenomena which are going on the outer level of the photosphere, outside of that, in the chromosphere and the corona, the great prominences and all the rest of it.
Oh, I imagine, are they planning for a nice, complete coverage of this particular
Well, I'm
eclipse?
sure they are. That's always the case. Unfortunately, I haven't heard any definite plans to cover this. It will be a little difficult to do because the islands across which the path of the eclipse will go are pretty wild ones. Borneo, the Celebes, and so on.
Oh, yeah.
And, in fact, eclipses seem to take a perverse delight in going across these out-of-the-way places like the middle of the Sahara or the wastes of the South Pacific. You can't do very much observing from a ship. I mean, you've got a moving platform there, the ship bobbing up and down. But usually, wherever there is to be an eclipse, parties of astronomers from observatories and so on will plan weeks ahead to observe it scientifically, to do all the things that they want to do to squeeze as much out as they can, because an eclipse doesn't last very long. The greatest duration of this eclipse, for example, is 4 minutes and 8 seconds in any one place. So you don't have very much time. And as a consequence of that, teams of astronomers who go to observe an eclipse will usually, if they can, conveniently and without going to too great an expense, set up a camp or a station. In the path of the eclipse where they can see it to the best possible advantage, and they will rehearse and drill and practice for weeks ahead of time so that every man knows just what he has to do every second of the few precious seconds that they have to see this thing.
Oh, yes, I can see
and
where
because
they have
it's
to
got
grab
to
it on
go,
the
it's
way
a
by.
commando raid, just bang, 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 each fellow doing just his thing. And the fellow better be sure to take the cap off the camera lens and all the rest of it, because that's it. When it's gone, it's gone, and you can't retake.
What kind of special equipment do they use, Jim?
Well, I don't know if there's anything too special about them. They're telescopes, of course, of various kinds, particularly adapted for solar work. spectroscopes to try and get a spectrum in the few minutes that they've got of the corona. The corona, that vague outermost envelope of the sun, is the thing that they know the very least about because it's hardest to see. It's kind of vague and faint, and they're trying to get more knowledge of it by analyzing its light, passing its light through a spectroscope or spectrograph, and getting a picture of the resulting lines and configurations, which will tell them more about the materials there and how they're reacting, what the forces are that seem to be playing upon them, and so on. And the cameras, telescopes, spectroscopes, things of that nature are the instruments they will have. And of course, these things are big and ponderous and have to be heavy because steadiness and absolute rigidity is the great requirement.
And I can see the chore getting into Borneo.
They build them out of bricks and everything else. And of course, just as a humorous sideline, invariably wherever they are camped, they'll have a violent rainstorm, clouds, and everything else. That's happened with many eclipses. The whole thing is always kind of... This is a rainy part of the world.
It is.
Oh, yeah.
Gee willikers, they're fighting the odds down there. Jim, you said earlier that we can get 3 to 5 eclipses per year. How many are scheduled for this year?
Oh, gee, let me see, Tex. I'm not sure. I should have dug that up. But as a rule, there are 2 eclipses of the moon and 5 of the sun. That's not as a rule. That's the maximum possible number. Usually we have 2 solar eclipses and 2 lunar eclipses, about 4.
Oh, yeah.
Now, as I recall it, this year we are not having a real, honest-to-goodness eclipse of the moon, for example. We have several what they call penumbral eclipses, in which the moon will pass through the outer fringe of the Earth's shadow.
Oh, yes.
And to anyone except an astronomer equipped with delicate instruments, nothing happens. I mean, that fringe is so delicate and so faint that the ordinary man in the street or even an astronomer without instruments could hardly perceive it.
Oh, yes.
So, of course, there's the circumstances that make an eclipse possible are very chancy. Everything's got to be working. It's just the sun in the right place and the moon in the right place, and so many things have to work together that it's a wonder we have any at all, to tell you the truth.
I was going to say, with all that space out there and these things flashing around in their own way, it's marvelous that they ever do coincide like that.
But they do.
I imagine then it would be a proper assumption, Jim, that since other planets are moving around in their own particular ways, do they have eclipses?
Well, they can have eclipses, of course, if they have satellites, because it is our satellite, for example, that causes an eclipse of the sun, the moon, which goes around the Earth. Now, Jupiter can probably have a pot full of eclipses because it's got 12 satellites, and it does. There are photographs taken of Jupiter, which include one of its larger satellites. It has 4 big ones. And you can see the Jupiter and the satellite in the picture, and then a little black spot on Jupiter, which is the shadow, of course, of the satellite cast upon the surface of Jupiter.
Oh, yes.
And if it were possible, of course, for you to be in that shadow, you'd see an eclipse. Now, it wouldn't be the same, I don't think, as an eclipse here. It's a little hard to say, because Jupiter's satellites are, the 4 big ones, are bigger than our moon slightly, and a couple of them are almost as big as the planet Mercury. And the sun, since it is 5 times as far away from Jupiter as it is from the Earth, would look a lot smaller. Perspective would make it smaller, so that the satellites of Jupiter, if they passed before the sun, would so cover it up that you wouldn't be able to see. There wouldn't be such a neat coincidence of size. Do you see what I mean? Be a big black thing sliding over and would hide the whole sun and the corona and everything else. If you could see it at all from that distance, I mean, here you're a lot farther away from the sun on Jupiter. The sun would have a smaller disk.
It'd be literally
and
nightfall.
their moons, if you want to call them that, I hate that because the moon is the name of our satellite. Their satellites would look as big and bigger than our satellite does because the distances are not excessive there. But a couple of them are about the same distance away from Jupiter as the moon is from the Earth. And they'd look just as big as the moon does, but the sun would look smaller, and consequently the eclipse would be just a dark place, that's all, a dark interval. And you wouldn't have, I don't believe, all the splendor of the hidden phenomena on the sun that we have here.
Incidentally, for you people at home, if you were finding this discussion interesting, may I suggest that you scratch around someplace and find a paper and pencil, because if you have an underlying interest in the stars and the planets, I'd like to mention a word to you for your fun and edification a little later in the program. And speaking of the fun aspect of this, Jim, it was, I think, a serious point in that so many people have associated phenomena and disaster with the association of themselves to the planets and the unknown world that is that marvelous canopy over them. Just for the fun size, we've so often heard the phrase, the moon and sixpence. Is there any background to that?
Well, yes. It's an odd thing, but any round or spherical object. Now, wait a minute. Let me start that better. The moon it's 109 times its own diameter away from us. In other words, if you take the diameter of the moon as we see it and multiply that by 109, that would equal the distance between us and the moon. The sun is 109 times its own diameter away from us, which is why they look to be the same size.
Oh.
Now, any round or spherical object, a soup plate, a basketball, or a dime, if it is held 109 times its own diameter from your eye, will look as big to you as the sun or the full moon. Try it sometime, and you try it with a dime. You'll have to get a friend you can trust to hold the dime for you, because your arm is a little bit not quite long enough to make it 100, but it will just cover up the moon. That's the moon and sixpence. On your point of view, the sixpence, if you're close enough to it, will look as big as the moon if you're far enough away from it, you see.
Oh, I'll be doggone. I never associated that. I thought maybe it had some mystic
no, I think
background to it.
That's the whole thing. It all, as I said, all depends on the point of view.
Well, how many astronomers cover an eclipse? You've talked about...
It's hard to say, Tex. I mean, as many as can get there.
Oh.
Now, for instance, a year ago, February, there was a total eclipse whose path lay right over Europe.
Mm-hmm.
Well, everybody and his brother was out for that one because they could just stick their heads out of the door. But this one, of course, being in a remote spot, it'll be just those fellows who have the time and the money and et cetera to get out there and establish camps. All who can will go. There'll be a lot fewer who can than an eclipse which took place over a more accessible and more populated area.
I was wondering whether perhaps it'd be associated with, say, the IGY or an international organization covering it.
Well, no, I don't think so. I don't believe that the IGY functions to that extent anymore. It may, and if it does, of course, it is still a collector of information, and such information as may be gotten from this will be channeled through the IGY, I'm sure.
Well, I was going to ask, all this accumulation, what happens to all of the information?
It goes into the general fund of knowledge. We are always learning. I mean, astronomy, for instance, has made more progress in the last 50 years than it did in all the thousands of years before it, and it's done that because not only are we getting more information through better techniques and better instruments, but we're cooperating to a greater extent. Everybody is contributing to the heap, to the fund, and we want to know, and everybody wants to know, and there's nothing classified about this stuff, thank goodness. I mean, we can trade it and talk it over and get the most out of it. But it'll all, each man down there, of course, and each institution will publish reports, papers, upon his particular field and his particular job and what he's had to do, and they will add to the sum total of what we all already know. Undoubtedly, each eclipse contributes some little additional fact or feature or something or other, which we didn't know before, and someday we'll have a lot. I don't know whether we'll have it all, but we'll have more.
Well, Jim, I think maybe we should recap that today is a rather special occasion in our skies, and that we will have a total eclipse seen just briefly on the west coast, but there will also be a strange conformation of the 5 visible planets. How will they actually be? Is it possible to describe them physically?
Yes.
Their layout?
We can do that. You can't see them, of course, let's face that, because they'll be right up there in the middle of the sun. If you happen to be in the eclipse path, and when the moon comes in front of the sun, the sky is darkened sufficiently, you could be able to catch a glimpse of these planets because they are all very bright, brighter than the stars because they're nearer to us. Actually, the planets... the planet Mercury will be above the sun as you look at it. And a little bit to the left of it. I'm putting it that way because I think that's easier to understand. Jupiter and Venus will be to the left and a little below the sun. Not directly below it, but off to the left, you see, where 7 and 8 o'clock would be on the clock. And Saturn and Mars will be over here where 3 o'clock and 4 o'clock are, and quite a bit farther to the right of the sun as you look at them. But, of course, as I say, outside of the few minutes of the eclipse, you wouldn't see them because the sun's brightness will overwhelm them. You couldn't see them anymore, and you could see stars in the daytime.
Yeah. It will certainly look like a gathering of the clan, though, if you did. could see them. I can see where, man might put some portent, but you're behind all of this gathering together in the stars, the sun and the moon and everybody
of course,
kind of piling up against it.
If I may just steal a little time, these 7 objects gave their name to the days of the week, you see.
Well,
you work it out.
True, yeah.
They're the old original 7 planets. They call the sun the moon planets because they moved.
Well, I never thought of that either. As you said, the participation of so many people in things, just like watching the eclipse, I'm wondering if our listeners ever stop to think that they, too, can participate in the work of the museum, and very directly by becoming a member. And in your particular field, Jim, I know that in every issue, and there are 10 issues of the magazine per year, you have the Sky Reporter that gives everyone just the position of the stars for that particular area, don't you?
Yes.
And a fascinating thing, if you have had an interest or a love for the stars, why, this is certainly your guidebook to it. And may I suggest that you don't just think about it, but to do something about it, to become a member of the museum. You not only help support their work, but you will receive 10 issues of a beautiful magazine, the Natural History magazine, all for the price of just $5 for 1 year. And again, a very definite and positive contribution on your part. All you have to do to get further information is just send your name and address to the Museum of Natural History, New York, 24, New York. It's that simple an address. But may I suggest again that you don't put it off. You will find it a most interesting and worthwhile investment. A member of the museum participating, and the magazine, too. Just your name and address to Museum of Natural History, New York, 24, New York. And thank you again, Jim, for joining us this morning.
Thank you, Tex. As always, it's been a lot of fun.
This is Tex Antoine reminding you to join us next Sunday at this same time when once again we journey into nature.
Journey into Nature has been a special program produced by WNBC in cooperation with the American Museum of Natural History. Join us again next week as we explore the museum, seeking out the natural wonders of our world. Journey into Nature is written and directed by Bill Wise, produced by Steve White. Your host is Tex Antoine. This is Fred Collins speaking. This program was pre-recorded and heard around the world through the facilities of the Voice of America.
People enjoy Manischewitz Concord grape wine better than
WNBC New York.
you